Hello and welcome to Albert Baboon Einstein. And there he is, my friends. He is a baboon. He looks exactly like Einstein, though, doesn't he? All right, super. Hey, first and foremost, make sure you have your notebook out and you're ready to take some good old notes. And here we go, my friends. Albert Baboon Einstein is conducting several experiments. He has 301.5 ounces of salt water. Now, each experiment will use 6.7 ounces of salt water, and you need to figure out how many experiments can Albert Baboon Einstein conduct. Well, this is a division problem. We're going to take 301.5 and divide it by 6.7. Let's go ahead and get started doing that right now, my friends. So here we go. I've got 301.5, and I'm dividing it by 6.7. Superb. All right, so the very first thing you always must do is move that decimal. You can never have your divisor have a decimal in it, okay? It's got to be over at the end. So that means I'm going to do one loop-a-doop here and move my decimal right there to make that a whole number, right? And if you do one loop-a-doop to your divisor, you also have to do one loop-a-doop to your dividend, and that's going to bring my decimal right there, and that is lovely, my friends. So first step, always make sure that your divisor is a whole number and move your decimal over with loop-a-doops if you have to. All right, next, I like to think of my divisor as gallons of water. And can you take 67 gallons of water and pour it into a 3-gallon hat, and no way it would spill all over the floor? How about a 30-gallon hat? Still no way, my friends. It would still spill all over the floor. And how about a 301-gallon hat? And you betcha you could put 67 gallons of water into a 301-gallon hat. So the next thing I like to do is get an estimator. And I always bump this number up. So I'm going to estimate this 67 as 70. So I'm going to plug a 70 in right here. And this is going to be my estimator. I'm going to use the 70 as my estimator. And that makes it really super simple because the 0 will hold the place value for the 1. And now all I have to do is think how many times 7 can go into 30, right? So, well, 7 times 4 is going to give you 28. And that's pretty darn close. So I'm going to plug a 4 in right there. So let's go ahead and do that. Plug my 4 right there, and now I'm working with the real number. 4 times 7 is going to give me 28. I'm going to drop my 8 and carry my 2. And then I've got 4 times 6, which is 24, plus this 2 is going to give me 26. I'm going to drop my 26, and then I'm ready to subtract. Now, I got some trouble coming, don't I? So I'm going to borrow from this. Actually, what I'm going to do is borrow from the 3 and turn that 3 into a 2. Then this would turn into 10. I'm going to borrow from the 10 and turn that into a 9 to turn this 1 into 11, if that makes sense, okay? So once again, the 1 was not big enough. So I borrowed from this 3, turned that into a 2 to make this a group of 10, and then borrowed from that, made it a 9, and made that 11. Superb, my friends. 11 minus 8 is going to give you 3. So let's go ahead and drop that 3. 9 minus 6 is also going to give you 3. Drop that 3. And 2 minus 2 zeros out. I don't have to do anything with that. So next I go back to the age-old question. Can you take 67 gallons of water and pour it into a 33-gallon hat? No way, my friend. So that means I'm ready to move over to the 5 and just drop that 5 straight on down. I'm going to extend this line and drop my 5. And now, can you take 67 gallons of water and put it into a 335-gallon hat? And you betcha you can. Now, once again, I'm going to use 70 as my estimator. The 0 will hold the place value for the 5. So how many times can 7 go into 33? And once again, I can only use 4 because 7 times 4 is 28. 7 times 5 is 35. And that's going to be too much. So I'm going to plug a 4 right there, right next to it. And here we go. Plug that 4 in. And then I'm working with a real number. 4 times 7 is going to give you 28. I'm going to drop the 8 and carry the 2. And then 4 times 6 is 24, plus 2 is going to give you 26. Drop the 2 and the 6. And now I'm ready to subtract. And let's enlarge this because, once again, I got trouble coming. So I'm going to borrow from the 3. The 3 is going to turn into a 2. And this 5 is going to turn into 15. And I got more trouble coming because I cannot take 2 and subtract 6. So I'm going to borrow from this 3 and turn that into a 2 and turn this 2 into 12. And 15 minus 8 is going to give me 7. Drop that 7. And then 12 minus 6 is going to give me 6. So drop that 6. And let's come back up here. And lo and behold, I can take 67 gallons of water and pour it into a 67-gallon hat one more time. And that's cool. But when I was young, I used to have to erase this and erase all that. And then my paper would get all messy. And then I now teach my students the build it up method. So write it in the same place value column. I'm going to add one more digit, and I'm going to add it the 1 there, right? So now 1 times 67 will give me 67 down here. 67 and 67 minus 67 zeroes out, right? And now I'm all done, other than with the build it up method, I've got to add these 2 up in this direction. So let's see how that works. I'm going to move this down a bit. And 4 and nothing is going to give me 4. So I'll bring my 4 straight on up there. And then here I've got 4 plus this 1, which is going to give me 5, right? So I've got 45. Now, the decimal could be brought up, but when you have a whole number, you really don't need that decimal there. So all you really need is 45, and that is really your answer. Let's go ahead and box that because I love to do it, right? And bam, there you have it. 45 is your answer. Let's come back here and look at the word problem and see what this actually means. So you got Albert Baboon Einstein here, and he's conducting a number of experiments. He's got 301.5 ounces of salt water, and he uses 6.7 ounces with each experiment. How many experiments can he conduct? Well, Albert Baboon Einstein can conduct 45 experiments, and that is a lot of experiments. He's going to learn a lot, and that is lovely. Hey, what I'd like you to do right now is back this video up to when I first started doing the division problem. And then what I'd like you to do is play a little pause and copy, play a little pause and copy, play a little pause and copy until you've completed the entire division problem with me side by side. And that is the fastest way to learn all these strategies for long division. And that's it, my friend. Until next time, I hope you have a fantastic day. I'll see you soon.